In this video we are going to be talking about harmony search algorithm. First of all, what is the harmony search algorithm? Harmony search algorithm was developed by Zhongwu Guim et al. In 2001. Based on mimicking process in performing music. It is inspired by perfect harmony like Beethoven's compositions. As everyone knows and loves, Beethoven's compositions are famous due to the perfect harmony in their foundation. The algorithm was based on musical performance processes. A musician searches for a better state of harmony. Thinks a pianist trying to find best harmony among all combinations. Types the notes like in his or her mind. And each time pianist check melody by listening to whether it sounds good or not. This process is similar to searching for a global solution of the optimization problem in a vast search space which has best solution among all combination. Jazz improvisation seeks to find musically pleasing harmony as determined by an aesthetic standard. Just as the optimization process seeks to find a global solution of the optimization problem. Similarly, the algorithm try to find best solution by mimicking this process. Why harmony search algorithm? The harmony search algorithm, which is one of the successful and robust algorithm in metaheuristic algorithms, has been preferred commonly since 2001 by many researchers. The first reason for the preference is its advantages. It is a powerful and effective optimization method with a simple structure, and this feature allows it to be used with other algorithms. It gives appropriate results in cases where the design space is infinite or so large that the entire solution cannot be evaluated. In cases where the number of iterations is high, it finds a reasonably good solution with fewer iterations. There is no need to specify a special initial value for the decision variables when starting the problem algorithm. It needs less math knowledge and no derivative knowledge. Since it continues optimization with more than one solution, it searches for the general optimum solution in many directions and does not get stuck with local optimum solutions. It can use both continuous, discrete, and integer variables. Another reason is that it can be easily applied to many different engineering problems effectively. The harmony search algorithm is easy to apply optimization problems, even complex and real-size ones. It is due to the simple nature of the algorithm and mathematical formulation. The relationship between harmony and music and harmony search algorithm is reasonable and apparent. It is given in here like this. Elements of the music process for performing match the basics of the harmony search algorithm, reasonably. The relationship between harmony in music and in the harmony search algorithm is clear and understandable. These figures shows the details of the analogy between music improvisation and engineering optimization. In music improvisation, each player sounds any pitch within the possible range, together making one harmony vector. If all the pitches make a good harmony, that experience is stored in each player's memory, and the possibility to make a good harmony is increased next time. Similarly, in engineering optimization, each decision variable initially chooses any value within the possible range, together making one solution vector. Consider a jazz trio composed of saxophone, double bass, and guitar. There exists certain amount of preferable pitches in each musician's memory. Saxophonist, do, mi, sol, double bassist, si, sol, re, and guitarist, la, fa, do. If first, second and third musicians choose so, si, and do among all possible values in their mind, respectively, a new harmony is obtained. And if this new harmony is better than existing worst harmony in the harmony memory, the new harmony is included in the harmony memory and the worst harmony is excluded from the harmony memory. This procedure is repeated until fantastic harmony is found. Think the same mathematically. If first, second and third variables choose 100 mm, 500 mm, and 400 mm among all possible values of them, respectively, a new solution is obtained. And if this new solution vector is better than existing worst vector in the harmony memory, the new vector is included in the harmony memory and the worst vector is excluded from the harmony memory. This procedure is repeated until certain termination criterion is satisfied. When creating a new harmony during a musician's music performance, 3 rules adapted to the harmony optimization algorithm are taken into account given in figures A, B and C. Plays a note in memory that is, a value can be selected from the harmony memory matrix. Can use a note that is adjacent to the note in his memory that is, the neighboring value of the possible value to be selected can be taken. You can randomly choose from among the notes. That is, it can choose a random value in the design space. Let's look at steps and flowchart of the algorithm. The first step is initialization. Initialize the optimization problem and algorithm parameters. These are parameters of harmony search algorithm. The first one is harmony memory size. It is the number of solution vectors in the harmony memory matrix. Harmony memory matrix in which the possible solutions are stored in it has number of row as harmony memory size. While each row of matrix correspond to a solution, each column belongs to a decision or design variable. The second parameter of harmony search algorithm is harmony memory consideration rate. Harmony memory consideration rate is the probability of choosing one value from the historic values stored in the harmony memory. And 1 - harmony memory consideration rate is the probability of randomly choosing one feasible value from design space. The third parameter of harmony search algorithm is pitch adjusting rate. The pitch adjusting process is performed only after a value is chosen from the harmony memory. The algorithm will choose a neighboring value with pitch adjusting rate multiplied by harmony memory consideration rate from harmony memory matrix. Maximum iteration number is determined in this step as termination criteria of the algorithm. Step 2 is initializing the harmony memory. A harmony memory matrix is formed and randomly filled with the design variable values. Each row of this matrix includes possible solution vectors. In figure, simple example is given to demonstrate this application of this step. As you see, harmony memory is formed randomly with chosen variables from design space. Step 3 is improvisation of a new harmony. A new harmony vector is generated from the harmony memory based on memory consideration rate, pitch adjustment rate, and randomization. In improvisation process, 3 rules which is used by musician in music performance are considered as probability of harmony memory consideration rate, pitch adjustment rate, and 1 - harmony memory consideration rate. First rule, an harmony memory consideration rate of 0.95 indicates that the HS algorithm will choose the design variable value from historically stored values in the memory with a 95% probability. The second rule is pitch adjusting process is performed only after a value is chosen from the harmony memory. The value 1 - pitch adjusting rate sets the rate of doing nothing. A pitch adjusting rate of 0.3 indicates that the algorithm will choose a neighboring value with 30% by harmony memory consideration rate probability from harmony memory. Third rule is a new harmony is chosen from the entire feasible range with a 5% probability or probability of 1 - harmony memory consideration rate. Step 4 is updating harmony memory. If the new harmony vector is better than the worst harmony in the memory in terms of the objective function value, the new harmony is included in the harmony memory and the existing worst harmony is excluded from the harmony memory. Step 5 is termination. Repeat steps 3 and 4 until the termination criterion is satisfied. In step 5, the computations are terminated when the termination criterion is satisfied. If not, steps 3 and 4 are repeated. Here, flowchart of harmony search algorithm in detail is given. Popularity of the harmony search algorithm. Harmony search algorithm studies, which is first started by Geim et al. In 2001, have continued with an increasing trend until today. Harmony search is a population-based metaheuristic optimization algorithm, which was initially proposed by Jong-Woo Geim in his PhD thesis. Even though it is now well known from the first journal publication, since then, it has obtained great success in various engineering applications, resulting numerous publications as suggested in figure. It shows a sustained and growing interest in harmony search method and its variants, particularly since 2011 in terms of number of publications on using of harmony search technique as shown in figure. But it is since 2006 in terms of the major modifications being made to change the algorithm structure as variants of them. Hybrid harmony search algorithms studies included setting algorithm parameters and hybridization of harmony search algorithm with other metaheuristic algorithms as well as collocation of the artificial intelligence algorithms, which are depicted in figure as the result of a comprehensive literature survey. According to the graph, harmony search hybrid optimization studies shows that hybrid studies of harmony search algorithm substantially have been preferred by researchers. In this video, harmony search algorithm has been explained in detail. Until now, harmony search algorithm, which is a robust and successful algorithm, has been used in hundreds of optimization studies. It seems to be continuously preferred thanks to pioneering researchers in optimization field. Thank you for your listening.